This is part 2 of the Newton's Law of Cooling videos. This is some examples of how we can use Newton's Law of Cooling. Newton's Law of Cooling can be used to do lots of different things. It can help you figure out how long an item of food should be in an oven in order to reach a certain temperature. It can tell you how long an item that's just come out of the oven is going to need to cool to a certain temperature. There's applications such as how long do plastics that are being formed need to be left out to cool long enough before they leave their molds. There's all sorts of different ways this can be used. But one way that you've actually seen a lot on television is when it comes to someone's death. You'll often see that they will proclaim the time of death, and the way they figure out the time of death has to do with the temperature of the body. Our bodies are normally 98.6 degrees. And obviously once we die, our body stops producing that heat and we slowly lose heat, and the rate at which we lose that heat depends on the temperature of the surroundings. Now look, the people even in real life, the coroners and the CSI type people, don't actually do the math for this, but they probably have a table or a chart or a computer program where they plug in the information and then they estimate that time of death. And the math that created those charts or tables or computer programs really did use this type of formula in order to determine it. So, we need to solve a murder. Turns out that Tony the Tiger was murdered in his high-rise apartment in New York City. Now, all we know is he was playing poker with several of his serial friends the night before, and there was a note found on the table saying, "I will snap, crackle, pop your neck." So we think we know who did it, but I guess we'll have to wait and see. So a normal tiger temperature is 101 degrees. At least that's Tony the Tiger's normal body temperature. And the temperature in his apartment was 76 degrees. Now when his body was discovered, it was 85 degrees, his body was. And then a half hour later, his body temperature was 80 degrees. So his body temperature dropped 5 degrees over the 30-minute period from when he was discovered to when they'd done other stuff and they came back and checked again. So the question is, how long had he been dead when he was discovered? Alright, so remember, our general formula here is y equals ce to the kt plus capital Ts. And we know that C is the initial difference between the body temperature and the room temperature. Okay, so that was 101 degrees minus 76 degrees, so our C is 25. So we can go ahead and plug that in. We don't know K, we don't know T, but we do know that temperature of the surroundings was 76 degrees. Okay, now the only thing we don't know that would complete our equation here is the K. And this actually gets a little bit complicated, so make sure you follow me real closely here. We're given two data points. We're given the fact that when he was discovered, he was 85 degrees, and a half hour later, or 30 minutes later, he was 80 degrees. So here's what we're going to do. We're going to plug 85 in for Y, the temperature of his body. But we don't know the time. We don't know the time at which this happened. All we know that this was the time at which he was discovered. So, for example, if this time turned out to be 90 minutes, then we would know that he was killed 90 minutes before he was discovered. So if we can figure out this time, the time it took him to reach 85 degrees, we'll know how long before he was discovered he was murdered. Alright, so that's one data point. The other data point is 80 degrees. Now we're told 80 degrees is the temperature he was 30 minutes later or half hour later than when he was originally discovered. So if this T represents when he was initially discovered, this T is going to be T plus 30. Okay, I'm going to put it in terms of minutes. Now if you would rather do it in terms of hours, you can do T plus 1/2, and that would be completely fine. Nothing wrong with that. Okay, but I want to explain this part again because this is key. At 85 degrees was he was 85 degrees at the time that he was discovered. He was 80 degrees 30 minutes after that time. So the time he was discovered plus 30. So this is going to allow us to solve for the K, and then we can solve other things. So the key here is that we are trying to solve a system of equations. We have a K and we have a T, and we have two different equations. If you remember back to Algebra 1 or Algebra 2 when you were first learning systems of equations, there are two basic methods you learned. One was substitution, and the other was called elimination. We could potentially use substitution here, but it'd be kind of tricky just because of all the e's and things like that. So it's probably not the method that I would recommend. Elimination, if you remember, is when you either added or subtracted two equations together, and that allowed you to eliminate one of the variables. We're going to do something similar here, but whether you knew it or not only are you allowed to add and subtract equations, you can also multiply and divide equations. So we're actually going to divide these two equations. Now before I do that, I'm going to simplify them a little bit. So I'm going to subtract 76 from both sides and rewrite my equations. So this one becomes 9 equals 25 e to the kt, and this one becomes 4 equals 25 e to the, and I'm going to go ahead and distribute the k here, k times t and k times 30. So kt plus 30k. Now I can divide these two equations. Because watch what happens when we divide. 9 over 4 is just 9/4. The 25's cancel out. And when you divide, think carefully. You got to think what we do with exponents. Whenever we divide, we subtract the exponents. So we're taking this exponent minus this exponent. So that's kt minus kt plus 30k. So the kt's cancel, and you just have negative 30k left over. So then we can take the natural log of both sides and divide by negative 30. And for now, I'll just leave this like this instead of approximating and using a decimal. So I know k equals the natural log of 9/4 minus 30. Okay, so now we have our completed equation. We can rewrite it as y equals 25 e to the natural log of 9/4 over negative 30 t plus 76. So this will allow us to solve for any time or any temperature we want to know. Well, we wanted to know the time it took for his body to reach 85 degrees. So we plug 85 in for y, and solve for time. Subtract 76 from both sides. Divide both sides by 25. Take the natural log of both sides. And the last step will be divide by that k value we have, natural log of 9/4 divided by negative 30. So divide that over, and you should get your answer. And it turns out to be 37.79 minutes, or 37.8 minutes about. So it turns out that it was about 37.8 minutes prior to being discovered that Tony the Tiger was murdered.